What if I told you that the fate of our planet's climate has always been written in the stars? Quite literally? For millions of years, Earth has danced to a cosmic rhythm, one so subtle, so vast that we barely noticed until now. Today, we dive deep into one of the most astonishing scientific revelations of our time, how Earth's orbit, tilt, and wobble, known as the Milankovitch Cycles, have shaped the rise and fall of ice ages, changed the course of evolution, and could determine the future of humanity itself. This isn't just science. This is a time machine. A new study has revealed incredible insights into the Milankovitch Cycles, crucial elements for predicting upcoming ice ages. While the next glaciation may seem far off, the Earth is already preparing for a period of cooling. This raises a fundamental question among scientists. Are we truly living in a stable and warm period, or is this warmth just a short pause between two ice ages? If the latter is true, all current climate forecasts could be wrong. And if the Gulf Stream is also slowing down, we might be heading toward a new ice age rather than a tropical climate catastrophe. In fact, glacial periods are not exceptions on Earth. They are integral parts of its long-term climate cycles. Over millions of years, the planet has gone through repeated episodes of extreme cooling, followed by warming periods and more moderate phases, like the one we're in now. Today, we have icy climates at the poles and tropical conditions near the equator. Even slight changes can drastically reshape Earth's climate. The Milankovitch cycles describe the changes in Earth's orbit, axial tilt, and precession, factors that affect how much sunlight reaches various parts of the planet. In addition to these, other forces like volcanic activity, ocean current shifts, and atmospheric greenhouse gases also play key roles. The last ice age ended around 12,000 years ago, a mere blink in geological time. If Earth is indeed in an interglacial period, meaning between two ice ages, then the next glaciation could occur within the next 10,000 to 20,000 years. However, human-induced climate change could drastically disrupt this natural cycle. It's still uncertain whether the current rise in CO2 will delay, prevent, or ironically accelerate this evolution. This new study offers astonishing conclusions. It is based on the groundbreaking work of Milutin Milankovitch, a Serbian mathematician and astrophysicist who discovered surprising patterns in Earth's climate in the early 20th century, while he was a prisoner of war. Milankovitch began calculating complex models of Earth's movements within the solar system. His idea was that long-term orbital fluctuations could be directly linked to glacial periods. Decades later, his calculations were confirmed, and today, Milankovitch cycles are foundational in climate science. His theory proposes that Earth's climate changes due to three cyclical variations in the planet's movement: eccentricity, the shape of the orbit; obliquity, the tilt of the Earth's axis; and precession, the wobble of the axis. These cycles influence the amount of solar energy Earth receives over long timescales, controlling whether ice sheets grow or shrink. Milankovich's calculations showed that ice ages always occur when certain alignments between tilt, wobble, and orbit overlap. Based on these cycles, we are currently in an interglacial phase that began about 12,000 years ago. The next glaciation is expected within 10,000 to 20,000 years. But the exciting question remains: how is human-driven climate change interfering with this cosmic rhythm? Milankovich's pioneering work demonstrated that Earth's climate fluctuations aren't random, but governed by a precise cosmic mechanism. Human activity might now be disrupting this system, and we don't yet know where that will lead. This is exactly what the new study aims to understand, to help humanity avoid missteps in climate protection. When will the next ice age begin? It's astonishing to think how far humanity has come in just the 12,000 years since the last ice age ended. It's worth asking, is human development also part of this cosmic clock? We are radically changing the climate, and scientists are examining how our actions might be influencing the Earth's systems. After the last ice age, glaciers retreated and temperatures became mild. But this warm phase is just a temporary pause in Earth's natural climate cycle. The question is not if, but when the next ice age will arrive. Milankovitch cycles reveal consistent patterns in Earth's orbital shape, axial tilt, and wobble. These cycles predict the next glacial period in 10,000 to 20,000 years. However, it's misleading to think that this event is still far off, because in reality, it has already begun. Time continues to pass, and Earth silently follows its cycles, regardless of what humans do or wish. The new study has shown that Earth's axial tilt, its obliquity, has already started to decrease. This means the gradual cooling has been underway for thousands of years. We have no influence over axial tilt or precession, but we do affect the atmosphere. Climate data reveals we've radically changed it in under 100 years. Industrialization and greenhouse gas emissions began about a century ago. The abnormal spike in CO2 and other gases may alter or delay the cycle. Some models suggest this warming could push back the next glaciation by tens of thousands of years. Others argue that Earth, as a complex system, might respond in the opposite way, triggering an early ice age to counter the abnormal warming. Current studies consider both outcomes plausible. At this point, we know far too little about the Earth's climate, the structure of its cycles, and its self-regulation mechanisms. What is certain, however, is that Earth has always recovered from disasters and extreme changes by adapting and balancing new conditions. Planetary and cosmic systems may possess an as-yet unrecognized intelligence that could help slow the damage caused by humanity. The Alanian impact, the asteroid that launched the first major ice age, is proof of Earth's ability to reset. Around 2.5 million years ago, an asteroid between 1 and 4 kilometers in diameter struck the Pacific Ocean at over 70,000 kilometers per hour. The impact released energy 1,000 times greater than modern nuclear weapons. A massive fireball ignited the sky in a split second. Water vaporized, gigantic tsunamis crashed onto coastlines, salt and steam reached the stratosphere, destroying the ozone layer, a process now echoed by today's greenhouse gases. But in this case, Earth cooled. Dust and salt in the atmosphere blocked sunlight, causing a rapid drop in temperature. This is how the Alanian impact likely triggered the first Quaternary Ice Age. Before that event, Earth was warm, with dense forests, giant mammals like mastodons and saber-toothed tigers, and a stable climate. But everything changed after the impact. Polar ice expanded, and weather became more unpredictable. Scientists found evidence of this in ice cores and sediment layers rich in iridium, an element commonly found in asteroids. Traces of the asteroid remain in Earth's rock layers today. Other global geological records show abrupt climate changes that cannot be explained by Milankovitch cycles alone. The asteroid started a chain reaction that led to an unnatural glacial period. The Alanian impact is one of the clearest examples of how cosmic catastrophes can influence Earth's climate and cycles. Without that event, the climate might never have changed so drastically, and early humans might have evolved in a completely different world. Violent events like these transform Earth. New life forms appear. Climate changes. Vegetation shifts. About 60 million years ago, a comet wiped out the dinosaurs. That, too, caused radical transformation. Life continued, and eventually gave rise to humanity. Now, how does the Gulf Stream influence glaciation? Almost the entire northern hemisphere and our civilizations benefit from the Gulf Stream. This massive oceanic heat pump transports warm water from the tropics northward, keeping Europe and North America mild. Without it, northern climates would be much colder. Ice sheets from the Arctic would expand southward, summers would shorten, and Europe's crops and vegetation zones would shift dramatically. If the Gulf Stream weakens or stops, it could trigger massive climate shifts, possibly even a new ice age, and this would be independent of Milankovitch's calculations. The Gulf Stream is part of the Atlantic meridional overturning circulation, a global current system we are only beginning to understand. Warm water flows north, cools, sinks, and returns southward, regulating climate and stabilizing weather. But what if this system slows or stops? Melting polar ice from Greenland and the Arctic is pouring vast amounts of fresh water into the North Atlantic. This dilutes the dense salty water, preventing it from sinking. If this continues, the entire current system could collapse. The result, significant cooling in Europe and North America, with fewer warm tropical winds reaching the north. North America could face stronger winter storms. Africa and the Amazon could suffer droughts from reduced humid air masses. A weakening or halt of the Gulf Stream could replicate the conditions that once triggered past ice ages. Scientists believe a similar shift 12,000 years ago caused the Younger Dryas, a sudden cold period that nearly triggered a mini ice age. Current studies indicate the Gulf Stream is now more unstable than it has been in over 1,000 years. The scenario: the beginning of the next ice age. Let's take a peek into the future. While we're still trying to understand and manage the greenhouse effect, unexpected changes could overturn the climate system. Temperatures might gradually decline. Snowfall could persist into late summer in temperate zones. Glaciers could begin growing again, and sea ice might stretch far south into the North Atlantic. The weakening Gulf Stream could begin showing catastrophic signs. Europe might be hit by increasingly severe snowstorms and brutal winters. Britain, Scandinavia, and much of northern Germany could become an uninhabitable tundra. In Canada and Siberia, current thawing of permafrost might suddenly stop. Sea levels would start to drop slowly as more water gets trapped in glaciers and ice caps. This would be the exact opposite of today's climate change narrative, focused on global warming and rising seas. If a new glaciation truly began, despite revised forecasts not expecting it for thousands of years, ice masses could eventually cover all of North America up to the Great Lakes and all of Europe down to central Italy. Cities like New York, London, Berlin, and Moscow would vanish beneath kilometers of ice. Life would shift toward the equator. Continental shifts, especially in Africa, could give rise to new human civilizations if humanity still exists by then. Earth's journey through space is not random. It follows a rhythm, a cosmic pattern that has shaped our climate for millions of years. And now we're finally beginning to decode that celestial code. But the real question is, now that we know, what will we do with this knowledge? Will we prepare for the changes ahead or continue to ignore the warnings just as we've done before? If this video sparked a new way of thinking about our planet, please hit that like button, share your thoughts in the comments, and subscribe to the channel so you don't miss future explorations into the mysteries of Earth and the universe. Share this video with someone who loves science, space, or the story of our planet, because sometimes the most important truths are written in the stars.